Okay, so here's where we take the stuff we did yesterday, looking for the zeros or the roots of quadratic functions, and combine it with the factoring we've been doing. Obviously, you knew there was a punchline coming to all this. Before we can get into the meat of it, we need to talk about the zero product property. That means any two things I multiply. Let's say they equal 0. One of those two things, or both, has to be 0. For instance, if I say I have x times y, and that equals 0. Well, if x is 0, and I don't care what y is, y could be 23, right? That's still 0. Or if y is 0, so if x is 15 times y being 0, I still get 0. So one of the two or both, right? 0 times 0 is 0. One of these two things or both has to be 0. The reason I bring that up is, let's take a look at this. If I give you the following, this is the factored form of something. So x plus 2 times x plus 3, and I say that equals 0. Right? Now, let's FOIL this back out. So back up one step. We get x squared plus 5x plus 6 equals 0. That might look familiar, like what we did yesterday, right? If you were to graph that. Well, if I'm trying to find the zeros, I can graph it, which we found how much fun that is, right? I can divide it out, or I'm sorry, I can find the square roots, right? Or, oddly enough, I can factor it, and then I can say, well, okay, one of these two things has to be 0 if my answer is 0. So either x plus 2 is 0, or x plus 3 is 0. In this case, that's going to make x is going to be negative 2, or x is going to be negative 3. One of those two then are the zeros, or the roots of this quadratic equation. That's where this whole thing's actually going. So to review this idea, the zero product property, oddly enough, I picked the same one here, right? So that means, again, if once I factor it, either this set is 0 or this is 0. In order to create the overall effect of being 0. Or they both are. I mean, it doesn't matter either way. So using that zero product property, so again, this is the factored form of some quadratic equation. So that means I take this set right here, set it equal to 0, and solve. Take this set it equal to 0, and solve. So I have two answers, negative 1/4 and 2. So that means if I were to graph this quadratic equation, again, obviously if I multiply that back out, it would cross the x-axis at negative 1/4, I'm sorry, and 2. That's what we're really doing with all this. So here we have A, B, C, and D, and these are, again, already factored forms. So here we're going to say x plus 1 equals 0, and x minus 5 equals 0. So obviously this is going to be x equals negative 1, and x equals positive 5. And we can see the answers down here. And for each of these, it's going to be the exact same thing. I'll work D for you just to make sure you've got the idea. So this was A, this is D. Otherwise, you can check the answers down here. So in D, 7n minus 2 equals 0, and 5n minus 4 equals 0. So add the 2, so 7n equals 2, divide the 7, and n equals 2 sevenths. Or add the 4, so 5n equals 4, divide the 5, and n is 4 fifths. So again, both of those are the zeros, or the roots of whatever quadratic equation this really is. And again, you can check the rest of them here on your own. If you get stuck with them, ask a friend, ask me. We'll go through and work them for you. So the idea being here that we can apply the zero product property to a quadratic function here. In this case, a quadratic equation. So we would take this one right here, and we would factor it like we've been practicing. And there's lots of methods we talked about here. So we're going to have x, and we're looking at the factors of 15. They're going to help us create 8 when added. Well, obviously that's going to be 5 times 3, and it's going to be x plus 5 and x plus 3. So that means I take x plus 5 and set it equal to 0, and x plus 3 and set it equal to 0. So subtract our 5 from both sides, and x is negative 5. Subtract our 3 from both sides, and x is negative 3. So our two zeros are negative 3 and negative 5. So in this example, we're going to go ahead and factor, starting with a right here, and the factored form, again, this whole thing equals 0. Factored form, I'm going to get m minus 7 and m plus 2. Again, if you're struggling with that, go back and take a look at some previous sections, all the stuff we've done there. Come and sit with me, and we'll work through them until you get them. So, again, that means m minus 7 equals 0, right? So m is a positive 7, and m plus 2 equals 0. So m equals negative 2. There's my two answers for that one. B, we're going to factor this one. We're going to get, alright, so equals 0. We're going to get p plus 5 and p minus 4. So that means p is going to equal negative 5 and p is going to equal positive 4. When you go to solve, again, remember each of those is set equal to 0 and then solved. Then this C might take you a little bit longer to solve. Let's see, 2 parentheses, all that equals 0, and I know for sure I'm going to have a 2a and an a, right? So that's the first place to start. Then we're looking for factors of 18 when multiplied, one of them at least by a 2, added together gives us negative 15. So we're looking for negative factors here, obviously, and we're going to find it's going to be negative 3 and negative 6. And how did I do that? Again, lots of practice, obviously. We have negative 3a and negative 12a makes negative 15a. So that's where I get that from. And then we solve, again, 2a minus 3 equals 0, a minus 6 equals 0. So a in this case is 3 halves, and a is a positive 6. And there you have the answers to these three. I know it should probably go without saying, but sometimes we're going to start out in not standard form, and you're going to skip that and ignore it and mess up. So don't. So we need to take this and put it in standard form first. Obviously the 18 should not be on this side. So subtract it, move it over. So now we have 4x squared minus 21x minus 18 equals 0. Now I can go ahead and factor this, 4x plus 3 and x minus 6, set it equal to 0. Solve both sides, and we get negative 3/4 and 6. Now imagine trying to do this using the squared method, right? Not really actually possible. Or imagine trying to do this graphing. That'd be a little tougher to try to get this negative 3/4 exactly. This one's going to start out again not standard form, so x squared plus 14x equals negative 49. Add that 49 to both sides, right? So add that 49 to both sides. So I get x squared plus 14x plus 49 equals 0. Then we're going to factor these. So we're going to get x and x, and in this case, we're going to get plus 7 and plus 7. You might have recognized the pattern here maybe, huh? So I only have to do one of them that are identical, so x is negative 7. Part B of this, why do quadratics in the form of this, right, or this, have only one real solution? Well, we should know these are the perfect squared trinomials. Kind of alluded to that when I said looking for the pattern here, right? So when we have that, and again, if you graph it, remember that's just going to hit in one point when you graph that equation. So again, when they're perfect squares, we know that it's the same thing repeated, so we only get one solution. So here's one of those lovely contrived story problems to make it sound like, ooh, we can use this in the real world sort of thing. So this one actually can be in construction and things like that, but this, not really this example, but we're going to do it anyway. You are constructing a frame for the rectangular photo shown. You want the frame to be the same width all the way around. Total area of the frame. So when I say that, what I mean is the area of the frame itself, right, all the way around here, not counting the stuff on the inside. Okay, should be 315 inches squared. What should the outer dimensions of the frame be? So one thing we're going to note here real quick, the outer dimensions, right? So this is x here, and oops, switch colors. The frame is x all the way around. So when we look at it, we're going to have the x here on the side, the x here, and then the 11. So this side is 2x plus 11. And likewise on this side, it's x all the way around, so there's the 2 x's plus the 17 noted here. And so again, to find that area, right, what we're looking for here is we're going to multiply those two things, 2x plus 11, 2x plus 17 equals 315. Decidedly not standard form. So multiply it out first. So this is where it gets a little hairy. Multiply it out, so FOIL it out. Then subtract that 315 from both sides. Now we have a standard form, right, quadratic. So thinking back to some other fun we've had before, factor out that 4. There's a common factor. Then we just go ahead and we factor the inside. Don't lose that 4 along the way. And so the 4 can never equal 0, so you really can kind of get rid of that, to tell you the truth, in the end. So we're going to say x plus 16 equals 0, and x minus 2 equals 0. So we have 16 and 2 as possible solutions, but 16 is not really a valid solution. You can't have negative distance. So in this case, 2 becomes the only valid solution out of this set. So you add it in, that gives us our, you doubled it obviously, right? So we'll take that 2x, so take that 2, plug it back into the 2 original factors we had here. So 2x plus 11 and 2x plus 17, and plug a 2 in for each of those, right, into the x, and we're going to have 15 and 21. All right, on this last one, very similar problem to the previous. Suppose this time, though, the area were 391. So it's going to start out very much the same, right? So we're going to have that 2x plus 11 and 2x plus 17. This time, though, it's going to equal 391. Go ahead and multiply that all the way out. So FOIL it out. 4x squared plus 56x plus 187 equals 391. Subtract our 391 so we can get into standard form. 4x squared plus 56x minus 204, that equals 0. Now we're going back and we're going to factor this thing. It's kind of backwards and forwards in this. Get that 4 out of the way first there. So 4 and then times x squared plus 14x minus 51 this time. All that equals 0. And kind of forget about the 4 at this point because 4 is not going to equal 0, so we're going to multiply by, so this is going to become the 0, right? So we're going to factor this out, and we have x minus 3 and x plus 17. That's 51, or 17 times 3 is 51, but again we're looking for a positive here, so the 17 gets the plus. That means x is going to be 3, or x is going to be negative 17. Well, that negative 17 is not going to yield a valid solution, so we're going to say x equals 3. Plug that back into these 2 originals. So in other words, we're going to have, give me a second, let me shrink some stuff out of the way here. We're going to have 2 times 3 plus 11, and that's going to equal 17, and we're going to have 2 times 3 plus 17, and that's going to equal 23. So our frame is going to be 17 by 23 inches.